שלום לכולם, אנחנו נמצאים בוובינר של האקדמיה של פרגון קבוצת ברנע. הוובינר פרויקט של קבוצת ברנע פרגון שמטרתו לחלוק ידע עם מומחים בארץ ובעולם בכל תחומי מניעת נזקי אש ועשן. השבוע הזמנו את ארמין פלטמן מחברת פוגטק. ארמין הוא חבר יקר לאורך שנים. כל מי שמסתובב בעולם בכנסים, העלו למיניהם כנסים בתחום המנהרות, תשתיות וכדומה, ודאי נתקל בארמין. ארמין אחראי בפוגטק על התחום של המנהרות תחבורה, להבדיל ממנהרות של רכבות, שבהם יש שליטה יותר על מטען האש. במנהרות רכב זה אתגר שונה, ארמין יספר עליו. מי שלא ראה אולי בתמונה של הכנס, אז רואים את ארמין, רואים אותו בפרויקט בסואץ, עומד לידו. עוד משהו קטן לגבי ארמין, מקור השם שלו, בטח כולם רואים עכשיו בנטפליקס את הסדרה על הברברים, השם ארמין, המקור שלו זה מארמניוס, שהוא גיבור הסדרה. אבל בואו, ארמין, please, you can begin.
Okay, so I hope you can see my screen. So thank you very much, Omri. Thank you, Paragon, for the opportunity to speak to the audience. Thank you, ladies and gentlemen, for participating in the webinar. It's a pleasure to speak to you about high-pressure water mist systems in tunnels. I will give a few slides, a few reference examples, and I'm very happy to receive your questions once the presentation is over. So please write the questions into the chat, and I'm happy to answer later. So the agenda. The agenda is the following. We'll have a introduction of myself, of our company Fogtech quickly. After that, I will answer the question, why would you actually put water mist systems into tunnels? Why do you do that? We will have some ideas about cost saving and compensation potential for water mist systems. An idea about reference example projects which we have carried out, where you can see a bit the reasons why these systems have been implemented. And then following up a conclusion, a close-up, thank you, and time for some questions. So this is me. I'm 42 years old. I'm working for Fogtech since more than 8 years now. I'm heading the tunnel business department at Fogtech. In normal times, I like to travel. I like to meet people. I like to do sports. See the beach, be in the mountains, do all these fun things, and I hope that this will be able soon again also to come to Israel for some interesting discussions on fire protection topics. So I would like to also get some idea who is actually watching the webinar, who is listening, to have the poll question also asked here. So what is your professional background? Are you a consultant? Are you maybe a tunnel operator or tunnel authority? Are you a contractor? Do you work with fire services? Are you a firefighting specialist or others? So please let me have your vote or let me have your click. So it would be very interesting to see where you are in the end coming from. Okay, I can't see any numbers now, but probably we can come back then later to this.
Armin, we can see the numbers. Just 1 second.
Oh, you can see the numbers. Okay, now I can also see. So, interesting.
Okay.
56% consultants. So welcome here. Welcome also to all others. Obviously, consultants. We are having many meetings, many discussions, and hopefully also one day we will have the same with you guys here. So thanks for voting. We will now then continue the webinar. So Fogtech is an owner-managed fire protection company. We are located here in Cologne. You can see in the picture where I'm actually standing now in the front of this building. We are a team of engineers, basically, working with lots of partner companies all over the world. Paragon is one of our partners. We are experts in firefighting, engineering, fire detection systems, water mist systems, control systems. And we have been doing this now for 20 years. I think it's now almost 23, 24 years. And we have become a leading company within some of the major applications as tunnels or trains for water mist systems. What are we doing? Big parts of our business is a consulting, development of protection concepts, fire testing. Smoke and fire testing is a big component to show that the systems are working or how they're performing with different fire loads. Engineering, component supply, firefighting and detection systems we are supplying. But we are also doing installation works ourselves. I guess Omri has mentioned the Suez tunnels already. There we are responsible for the turnkey supply of the system. So project management, part of it, service, maintenance, and operations. So very broad variety of supplies, which also gives us the inside view of how the projects then really work. Just a quick look to the businesses we are in. The so-called fixed business is the units where we work with buildings and then industrial applications. Railway systems, we have water mist systems on boards in the train, dedicated detection systems, overall controls of the system, allowing to compensate other safety deficits in a train or allow the train manufacturer to build the train in a different way to save weight, save costs by using a water mist system. And then tunnel systems, the reason why we are speaking here today, why you are listening, is the third pillar or main pillar of the company. We are quite active in all kinds of memberships and networking associations. For example, NFPA 502, we are sitting in a technical committee. Myself, I'm sitting in a technical committee since a few months. We have done lots of research projects to find out how the systems are working, how are they interacting with the ventilation system, what are the temperatures in the tunnel, can people still see when the system is activated, and all these kind of questions we are finding out in these research projects. So this eats also quite some time for the company, but gives us a major benefit to understand what's really happening. Lots of fire testing, as I said, probably you might know some of the clients, Eurotunnel, Tunnel Mont Blanc. We have carried out full-scale fire tests, as you can see in the pictures, with fire loads of more than 200 megawatts. More than 200 fire tests have been carried out. So we have a very profound understanding of what's going on in these critical situations in tunnels. A small video showing a crash in a tunnel in Slovenia. Please pay attention to the time at the lower right of the video. It will skip a bit. You see that the driver is running into the wrong direction. The smoke is being pushed downwards the tunnel. The detection system now hits in, so very fast detection of the fire. Very quickly you can see that the tunnel is completely filled with smoke. It's not even 2 minutes have elapsed. The fire is spreading from one vehicle to the other. And you will soon see at the other side of the tunnel the massive amount of smoke which is coming up. We are now approximately 3 minutes after the crash has happened. And the fire has already evolved extremely strong, although it's not even a liquid fire. Now, this is the amount of smoke. Imagine no firefighter would be able to go in from this side. Very critical situation. And these are the kind of accidents or reasons why you put water mist systems into a tunnel. You see now the cross-section is filled with smoke. Very, very difficult situation. So a bit of the theory to understand what's going on in these moments. You see a typical fire curve of a tunnel fire development. This is what different fire curves in the world look like. The one is a bit more steep, the other is a bit longer. but this is kind of the typical scenario that we are having. So a relatively slow first development of the fire, then in phase 2, a very strong growth, and then typically the fire will stay at a very high level in the tunnel, which then also leads to problems for the tunnel structure. What we do with the water mist system is we are trying to cut this curve. Yeah? We activate as soon as possible. As soon as the fire has been detected, the water mist system will be activated, and we are bringing down this fire curve to a low level. Yeah? So the consequences of this fire will not be as massive as you have seen in the video, but the fire curve will come down with several benefits for all parties involved into these scenarios. So what does this actually mean? Sure, we will improve the life safety, the temperatures will go down, we will limit the amount of smoke. The firefighters will also be able to go into the tunnel to really fight the fire, to access the fire. And bringing down the temperature also means that we will protect the structure of the tunnel. So these are kind of the direct benefits which are relatively obvious for such an active firefighting system. But there's also measures which have kind of secondary effects, which then also allow a holistic view, an integrated view to tunnel safety, including water mist systems. So we can actually reduce or improve the performance of the ventilation system. The water mist system reduces the amount of smoke, which means that the ventilation system has to drag away less smoke than compared to with no water mist system. So in many cases or many tunnels here in Europe, we have lots of old tunnels which do not really meet the requirements of modern design fires. So they were designed 30, 40, 50 years ago. Different fire loads were considered. So we have seen that in many cases, the ventilation system was not able to push out the smoke efficiently outside the tunnel. We have seen in fire tests that the back layering has occurred, which means that the fire actually comes back to the ventilation direction, which is very critical because you want to keep this side of the tunnel clear of smoke for the people, for the life safety. And when doing the fire tests, we have seen that even in late activation, the water mist system has brought down the fire size, the amount of smoke, and the ventilation systems were able to push out the smoke of the tunnel. So let's assume we're having a fire size of 100 megawatt in the tunnel. We will activate the water mist system, push it down to maybe 25, 30, 35, doesn't matter. Reduce the amount of megawatts in the tunnel, reduce the amount of smoke, and then even having a kind of 100 megawatt fire load burning in the tunnel, a ventilation system which is maybe designed for 30 megawatt only, as we have for many systems. The ventilation system can, in combination with the water mist system, still push out the smoke out of the tunnel without any back layering. So putting a water mist system into the tunnel may improve the performance of your ventilation system for even severe fires. The protection of the tunnel structure. This is a very important reason or very important a factor for putting in water mist systems into tunnels. These pictures, they show severe tunnel fires from the past, show that actually when the structure is exposed to high temperatures for a very long period, the concrete might spoil, it might crack, it falls down. For example, on the left-hand side, this is what you see in the Mont Blanc tunnel, which has led to the drastic consequences and fatalities which we had. So in order to really check if the system is capable to protect this tunnel efficiently, we have done another fire test. You can see the truck on the lower side. There's a dot where we put a certain test equipment, and you can see that the test equipment has been, we have put sensors into different layers of the test equipment, into the concrete block, to understand how will the temperatures be inside the concrete. It's not really relevant to see how are the temperatures directly inside the tunnel, but more inside the concrete to prevent that the concrete will crack in case of a fire. So 150 megawatt fire load, a sensor every centimeter in depth. And then we could see that actually the water mist system has limited the temperatures after activation to maximum temperatures of around 250 degrees inside the concrete. So the critical values for the spalling have not been reached. Yeah, we are far below the critical values. The system was able to protect the tunnel structure efficiently, which then also again means that you are able to compensate potentially missing passive fire protection measures or tunnel structure protection measures with a water mist system. One very important reason for a water mist system in the tunnel is to keep your tunnel up and running, even though you have a severe truck fire inside the tunnel. So we want to avoid these kind of congestions. We want to avoid that our infrastructure has to close down for several months or even several years. And we also would be able to refurbish a tunnel relatively easy and upgrade the tunnel with a water mist system. Yeah, so maybe one example, there was a fire in one of our tunnels in London. A car was burning. There were some repairs were going on. The system was activated relatively quickly. The temperatures were cooled down, and we could see that there was actually no damage inside the tunnel, which means that the tunnel was open again after 1 hour 23 minutes, so roughly 1.5 hours, and the tunnel was opened again for traffic very soon after this incident. And this is one of the major benefits that such a system will also provide. The Mont Blanc tunnel, I don't want to go into details, but just as a very severe example of consequences of fires in tunnel. Obviously, we know that 39 people have been killed, but I want to point out that the tunnel was also closed for 3 years because of the refurbishment requirements, the upgrade requirements after the incidents, and the very high external costs for the society. I'm not speaking of the direct repair costs of this tunnel, but all the consequences which the society might have when passing by different routes, abrasion of the surrounding roads, which have to be refurbished later on. So a massive harm to the economy and the society for such a tunnel closure. And this for sure would have been possible to avoid with an active fire suppression system in the tunnel. Now, this obviously allows you to not only spend additional money to a system, which all of us want to avoid, but we want to be clever and integrate such a system into the overall safety concept of the tunnel. Yeah, meaning that maybe we don't need big jet fans if we have a water mist system. Yeah? The fire brigade might allow for 15 or 20 minutes more time to enter the tunnel, because the water mist system will keep the fire under control. And all these kind of things, all these reasons jointly will allow you to even save costs putting such a system into a tunnel. A few reference examples to just show how these systems are being implemented, how they work. The Dartford tunnel in London, I just mentioned already the fire we had a few years back. This is how it looks like, very old tunnel. It's a tunnel with actually concrete with cast iron linings, so very sensitive to temperatures. It's going below the River Thames in London, so also critical piece of infrastructure. We're having 2 pump stations here, diesel-driven pumps, so very reliable system. A SIL2 rated control system, which is a very high sophisticated control system to keep the system up and running at basically any time. And a section valve which allows for easy maintenance without closing the tunnel. Everything was done in 3D. We had very short installation times only, a very high level of prefabrication to minimize the time inside the tunnel, and installation without the budget and time frame. I said already the cast iron lining was a very sensitive part of this project. The European law required to upgrade the safety systems of the tunnels, ventilation, structure protection, life safety issues. So these were the main reasons why the water mist system was chosen. It was not possible to upgrade passive protection measures. They could not close the tunnel for several weeks. And you have to check the tunnel, especially when being below the river, for possible leakages. Very high availability requirements. And as this is a kind of private run tunnel, each and every car pays toll to go through the tunnel. The business continuity of such an infrastructure is obviously crucial importance. We are about to finish the works in Egypt in 2 tunnels, very exciting projects, very special projects also for us. We are protecting the Ismailia and Port Said tunnels in Egypt, which go below the Suez Channel, 5 kilometer long, and the other one is 3.5 kilometer long, of very high strategic importance for the Egyptian government. Engineering authorities of the armed forces are the end client, and the construction is done by an Egyptian joint venture of 2 construction companies. So you can see me actually here during the early construction phase when we were bidding for the project. Oops, that was the wrong direction. So again, we had to provide a fire-tested system. We have to prove that the technology was working. The traffic in Egypt is a bit different than what we are used to. Cars are probably catching fire a bit easily, trucks not in a very good maintenance status. It's an underwater tunnel, so critical infrastructure. It was designed to fight a fire of 200 megawatts, so really severe fire load. And all this was done in cooperation with also international consultants working on this project. Some technical details: 2 pump stations were installed. We have a total flow rate of around 3,900 liters a minute, 5 high pressure pumps, 1 redundant pump units as a backup, a sophisticated section valve allowing the remote maintenance without closing the tunnel, without extra costs, and a very high system availability, which then also leads to low maintenance costs for the client. A few more pictures of the tunnel during the construction phase or installation phase. The installation was carried out by our local partner under Fogtech's responsibility, so we were the main contractor, and we did this with a very high level of prefabrication to minimize the time, the working time inside the tunnel. One other project which we are currently finishing, let's say also in these difficult COVID-19 times, still ongoing, is the U-Carry tunnel in New York, also known as the Brooklyn Battery Tunnel. Probably one or the other has heard of it, or has even driven through this tunnel. It's a very old tunnel from 1950, very narrow, very slim, little space, 2.8 kilometers long, 2 bores, connecting Brooklyn and Manhattan, so below the Hudson River. The requirement was to upgrade the safety system and the ventilation system. You can imagine 1950, the requirements were a bit different for tunnel safety systems. And we had to do all this, or the contractor had to do all this during full tunnel operation, so very challenging in such a busy city. You can see, by the way, a picture from 1954, I think, when the ventilation tests was carried out with running cars, so quite different times back then. We had to install the nozzles in this ventilation duct. You can see that there's some very slim ventilation openings, so kind of old ventilation system. It was not allowed to install any of the components really inside the road tunnel because there's no space. Everything had to go into the upper ventilation duct, as you can see. So we had to think of some clever pipework routing, space-saving installation, and only protecting the tunnel with only 1 pump station, as space is also a critical factor in New York. The design was done according to the national guidelines, NFPA 502, NFPA 750, and the solid guideline. We had a full-scale fire-tested system, So we did not have to do any fire tests again because we could already prove that the system is working efficiently. And as a verification that the system would also work in combination with such a ventilation system, an on-site testing was done to verify that the water mist would not be sucked into the ventilation ducts. And you can see in the middle picture that the nozzle is going through these ventilation ducts here. So before I want to close my session, my presentation, with a conclusion, I would actually like to ask you another question. After having received a few more impressions of water mist systems in tunnels, I would ask you, what is the main reason for a water mist system in a tunnel? Would it be life safety, safe access for firefighters, protecting the tunnel structure, increasing or maintaining the availability of the infrastructure, compensating existing deficits which might be there in all tunnels, or are there other reasons why such a system would be installed? Please give me your vote. I'm very curious to see what you would consider from the Israeli point of view, basically, why such a system would be put into a tunnel.
Wait a few seconds because I can see that people are still voting.
Yes, of course. We should take your time and think a bit what's possible here.
Oh, whoa, a lot of people are voting. Good.
Very good. So we get a representative result of the people's votes.
Yeah, I think we can end the poll now.
Okay. Oh wow, that's actually a very interesting result. I had no idea what would come out. So life safety with 81% is seems to be the main reason why you would put a water mist system into a tunnel. Safe access for firefighters 4%, tunnel structure protection 11%, and availability of the infrastructure 4%. Now, I guess there's no really right or wrong answer. There's multiple reasons why to put such a system inside a tunnel. It really depends on the tunnel itself. Every tunnel is different. We have different legislations, different requirements. Do we have a public tunnel? Is it a toll tunnel? Do we have a public authority, which is taking the decision, or is it kind of a private run decision? So there's no really right or wrong answer. Certainly life safety is one of the main reasons, but very high on the list from our point of view and experience is also the tunnel structure protection and keeping also the availability of the infrastructure at a high level, especially in countries or in cities where we have very high risk of congestion for traffic. Okay, so this leads me to my conclusion. I think we have seen and learned that water mist systems in tunnels, they also provide major benefits, life safety, fire services, access, increased structure protection measures, compensation of existing deficits, especially for upgrades. This is a reason, but also that we can actually save costs when implementing this into the overall safety concept of a tunnel. And we have also seen that the technology is actually accepted. It's now coming into more and more tunnels, especially critical tunnels. And it can also be very effective for tunnel refurbishments. So I'm thanking you already now for your attention, for listening. Feel free to contact me at any time. And I'm very happy to give the word now to Omri and to come up with a few questions from the audience that may have arisen.
Thank you very much, Armin. If anybody wants to ask questions, you have Q&A. I can see one question. There is one question regarding about the amount of water that's needed for this kind of project. If you can, let's say, Suez project or something like close to us.
That's a very good question. It really heavily depends on the size of your tunnel and the length which you will protect the tunnel. So typically we would design the system in a way that we operate or activate 3 sections. So one section where we have the fire, one section before, and one section afterwards. Typical section length is somewhere around 25 meters. So 3 sections would lead to 75-meter protected length. In Egypt, as I said, for this tunnel, we had roughly around 3,900 liters, including some safety factor. This is also a very high tunnel, so we will have an increased amount of water to fill the entire cross-section of the tunnel. And these values, these water amount values, they are deriving from the fire tests. So we are taking the design of our systems based on the fire test experience which we have. We are kind of copying the layout from the fire tests, then into the real tunnel, adopting it, modifying it to suit the new tunnel cross-section. And this is how the water amount will be calculated. If you compare this with a, let's say, traditional sprinkler system for tunnel, you would probably need to multiply the amount of water by a factor 2.5 to 3.5. So for this tunnel, we would probably have around 12,000 liters of water per minute, so even far more water than you're already having with the water mist system.
Okay. Another question, is there any NFPA direct connection between ventilation capacity and use of mist?
There is some statements in NFPA 502 which allow to kind of take the compensation or the positive impact of the water mist system into account when designing the ventilation system. There's no such calculation saying that, okay, you put a water mist system, you can half the size of the ventilation, anything like that. Yeah, but you would need to do kind of an engineering analysis where you, as a consultant, as a designer, or as a supplier, would then show that the system, based on the fire tests results, would be able to suppress a fire down to this and that value, and that this and that consequences would be there for the ventilation system. So positive consequences, reducing the size of the ventilation system. And this has been done in a few tunnels, and is a common practice also nowadays.
Okay, and another question is regarding the pipes. What is the material of the pipes? Is it stainless steel 316 or 304?
Yeah, very good question. Typically, it's stainless steel 316. We use for the main pipe, so the pipe which is constantly filled with water, so-called duplex steel material, which is even a bit more corrosion resistant and a bit stronger. However, it's mostly related to the local legislation or requirements. In most countries in Europe, at least I can tell, that we have 316 Ti or 316L as a minimum requirement for the pipework, but also for the supports of the system, which basically is the case because of the corrosion resistance and the long lifetime of these components.
Okay, another question regarding that is, are we getting a lot of steam from the high temperature and of the water mist? The high temperature of the fire when you use the water mist, sorry.
Yeah, also very good question, asked also relatively frequently. We will get some steam very locally, yeah, so it will, the cross section will not be filled with kind of a very fine steam, but more like with a mist. There will be a steam very locally, like I can't tell you in centimeters, but just at the fire source, the water will evaporate, which also leads them to the fact that the connection between the oxygen and the fire is kind of broken, that the fire will to some extent be suffocated. If I may give an example of other applications, basically every cruise ship, or 90% of the cruise ships in the world, they have water mist systems on board. So yes, they would also have very little amount of vaporized water, yes, but very little amount of fine steam. But it does not harm to any people. Otherwise, obviously, would not be installed in ships where you have several thousand people on board.
Yeah, makes sense. There is another question. What is the advantage of mist system comparing to the loose system on tunnels?
Also very good question. From the firefighting performance, there's some differences to start in that way. The water mist system works a bit more three-dimensional, so meaning that as the mist is finer than the deluge system, it will also be located around the tunnel ceiling. So for the tunnel structure protection, the water mist system is more efficient. Fighting Class B fires also works better with water mist. We have seen that in many tests. So they're actually, as far as I know, no tests have been carried out with deluge systems and Class B fires, so liquid fires. Obviously, the amount of water is far less with water mist system, which means that you have smaller pipe works, smaller components. Your drainage requirements can be lower. Yeah, you don't need to bring 12,000 liters to the drain, but only 3,000 to 4,000 liters, let's say. Of course, we're having a higher pressure, so the components would also be suited than for higher pressure. And if we are speaking of, let's say, tunnel like in Egypt, where we are 3.5 or 5 kilometers, we also put quite some significant amount of steel into the tunnel. So if you're having a main pipe size, which is 2 or 3 times as large as for a water mist system, also the costs, the weight, the water storage size, all these things will be far better than with far larger than for a water mist system.
Okay.
No?
Okay. Two last questions. You can have water. Yeah. Okay. Is mist system is used for a tunnel that is used to transfer chemicals? Do you have any experience with that, or did you hear about it?
I think the question refers to what happens when we have chemicals which are water reactive. I believe this is a question which comes from time to time. So yeah, it's a good question. It can't be answered with yes or no, but we would say yes, it can be. First of all, not all tunnels are open for, let's say, all categories of fright. So when we are having very sensitive chemicals, in some cases, the truck will be escorted by some safety cars. We have this in the tunnel in London, for example. If this truck would catch a fire in the tunnel, it would normally be at the brakes, it would be at the exhaust pipe, it might be some electrical reaction in the car which leads to a fire. It might be a tire which is rubbing somewhere. So the root cause of the fire is not the chemical tank itself, but it's somewhere around the car, yeah, or an accident would be. And these transporters, they are, or the parts where the chemicals are transported, they are secured in such a way that they will not rip very easily. They will not rip if there's an accident. And the water mist system will rather allow, or will rather cool down the temperature, will bring down the fire size, so that the fire will not be the cause to rip the tank, yeah, to lighten up the tank, to break the tank. So we see it rather as a positive consequence, being able to prevent that this chemical will catch fire and will then come in contact with water, rather than not doing anything and maybe having the truck burning, leading to the chemical also start to get fire.
Okay, one last question. Okay, last question. What is the influence of the height of the tunnel and the efficiency of the water mist system?
Very good question also, I think. The tunnels in the world are getting bigger and bigger, are getting higher and higher. And we have to take this into account for the firefighting. So Obviously, the higher the tunnel, the easier it will be to fight or to cool the tunnel structure of the tunnel, yeah, because the flames will not impinge directly to the tunnel ceiling. On the other hand, we have to fill the entire cross section with water mist. So the higher the tunnel gets, the more mortar we would put into the cross section. So we will do kind of a volumetric based design approach, meaning that we will calculate how big is the cross section, how big is the section of 25 meters, what have we done in the fire tests, and transfer this value then to the tunnel. So if we have a tunnel which is, let's say, 7 meter high compared to a tunnel which is 5 meter high, we would increase the amount of water to compensate the kind of the missing height or the missing area.
Okay. Okay, thanks for your lecture and for your time. It was interesting. We have also a lot of other questions, but we will gather the questions and we will send it to you.
Yes.
And some of the questions will be answered by Nadav, our engineer in Israel.
Very good.
And yeah, and thank you very much. I will speak in Hebrew to present the next lecture. And
let me say thank you quickly, and I'm open for any further questions. Contact me or Omri, and I'm happy to assist for anything that might come up. Thank you very much.
Thank you very much. Bye.
Bye bye.
ביי. טוב, עוד פעם, תודה לארמין. אני אגיד כמה מילים על ההרצאה הבאה. ההרצאה הבאה יעביר אותה מקס לקונן, מנכ"ל מעבדת אייפאב. ההרצאה תהיה שבוע הבא, לא בעוד שבועיים, תהיה שבוע הבא ביום רביעי, בשעה זהה. מקס לקונן איש מאוד מעניין. אתם תראו גם כבר בתמונה של ההזמנה לוובינר. זו תמונה שהוא של הזוהר הצפוני, הוא בחור מפינלנד, מאוד מאוד אוהב להסתובב ולצלם צילומים יפים. איש מאוד מיוחד בנושא של ניהול המעבדות וניסוי אש, והוא ידבר בעיקר על נושא הרכבים האלטרנטיביים, על איך שבעצם המערכות כיבוי הקיימות היום, מותאמות לרכבים שקיימים היום, ולא לרכבי העתיד. והוא שותף בניסוי שנקרא, בפרויקט שנקרא סוברן, של ממשלת שוודיה וגרמניה, במימון של הממשלות. הוא ניהל את הנושא של כל ניסוי אש, ויהיה מעניין לשמוע ולראות ולהבין את הנושא. אז תודה רבה לכולם, וכמו שאנחנו רגילים, הנה ההרצאה הזה, מקס באמצע, ורואים את הזוהר הצפוני ברקע, אחת התמונות שהוא שולח לי. אנחנו נשלח בימים הקרובים את הלינק להרצאה, ויהיה מעניין, וכרגיל ההרצאה תעלה לדף האקדמיה ביוטיוב, אם רושמים אקדמיה פרגון, אפשר גם להירשם לערוץ היוטיוב, ואז לראות כל פעם שעולה הרצאה חדשה. שבוע הבא תעלה גם הרצאה קודמת כבר מתורגמת, וכנ"ל בערך בעוד 10 ימים תעלה הרצאה של ארמין מתורגמת. אז again, Armin, thank you, and thanks for everybody for joining. Bye.
Thank you. Bye-bye.